Welcome to another video. In this system of functional equations of f of x plus 1 equals to f of x plus 2 plus 1, we want to solve for f of x in this problem. But looking at this problem, so we're trying to use manipulation method, we might not get it, or trying to use substitution method, we might not get it. And we should know that x is a member of real number. Okay, let's see how to solve this. We have f of x plus 1 equals to, so if I split this x plus 2, so it becomes f of x plus 1 bracket then plus 1. So we give a under bracket then plus 1 outside. So let's replace x plus 1 with x, and hereby we have f of x equals to, so since we have replaced x plus 1, then we have x plus 1 again, then plus 1. So alright, so as I told you earlier that we cannot use substitution method here, so as we keep coming back to the real questions. So, and x is the member of real number. If I start testing for, let's say at x equals to 0, so by replacing x with 0 here, we have f of 0 equals to, here is f of 1 plus 1. So we can conclude the result here. So let me test for x equals to 1. Then we have f of 1 equals to f of 2 plus 1. And this is how this number will keep increasing till as many as we test for the positive real number. And since 1 here is a constant value for the positive real number, and we can still check for the negative one, so if the one will remain constant. So by checking for this, so here becomes f of 0 plus 1. And you must have observed something here, that for the positive real number, so the other side keep increasing, while for the negative, the other side keep decreasing. So this is what brought to this assumption, and I assume that if I let f of x equals to a constant value, suppose I choose mx, that is, we define x based on the function m. Okay, if this equals to mx, then from the other side, which is f of x plus 1, so that one will becomes f of x plus 1 equals to m is a constant value, we take it out, then x plus 1 will be in the bracket. And by opening the parentheses here, we have mx plus m. So let's combine these two together from the this line that we derived. So if I combine these two as f of x equals to f of x plus 1 then plus 1, and we know that the f of x from the assumption is mx. So we have mx equals to, y f of x plus 1 is mx plus m then plus 1. And wow, so we can derive something here. Mx is common, so which means these two negate each other and become 0. Then we have 0 here equals to m plus 1. And we got the value of m as negative 1. So if m equals to negative 1, you must have guessed by now that the function that we are looking for, which is f of x, is equivalent to minus x. But can we conclude that this function that we just got now is the real result we are looking for. Okay, so we can guess, but let's verify if this is going to be equal. And if you have from the above f of x plus 1, so this is going to be negative bracket x plus 1 from what you got above, f of x equals to negative x. And for the second, for the other side, we have f of x plus 2, so which means this will also change to negative bracket x plus 2. But is this two equal? No. But don't forget that there is 1 added to f of x plus 2 at the other side. So if you add this to it, so which means that we are going to get the result. But let's see how the result comes. Here is, by opening the bracket, we have negative x negative 2 plus 1. And the entire of this is negative x negative 1. And by factorizing out negative, we have negative bracket x plus 1. Wow. So which means that the left hand side here equals to the right hand side, and the f of x, which is equals to negative x that I got, so is truly the real function that we are looking for. So f of x equals to negative x, and this is true for the real number. So this is how to solve this problem, and I hope you learned something today. Thanks for watching. Don't forget the steps that I used. Subscribe to this channel and like this video. And if you have a better way of solving this, you can drop it in the comment box. Never stop learning.